Let's take a look at question 13. We're to find the value of a that will make the function g of x equals 2x minus 5 when x is less than 3, and 4ax minus 2 when x is greater than or equal to 3 continuous. Okay, so what you want to note here in this piecewise defined function is that 4ax minus 2 includes the point x equals 3 and any value that is greater than 3. Alright, so to give you a visual of the situation, let's represent this situation on a number line so we can assign intervals and boundary points to the functions. So we're taking a look at what's happening around x equals 3. To the left of 3, we have an open circle and the number line heading in the leftward direction. So in this interval, x is less than 3, the function under consideration is 2x minus 5. Now, to the right of x equals 3, including the value x equals 3, we have a closed circle and the line going to the right. So for this interval, this is x is greater than or equal to 3. We have the function 4ax minus 2. So one thing you want to note is that in this situation, the value of the function f of 3 is equal to the limit as x approaches 3 from the right of the function, okay, of g of x. So let's label this. This is g. The name of our function is g, so let's label that g. So when we are proving continuity, we do not need 3 conditions. We just have to show that the left and the right hand limits are the same. So in order for the function to be continuous at x equals 3, initially we have to show that the limit as x approaches 3 from the left of g of x is equal to g of 3, the value of the function at x equals 3, and that also has to be equal to the limit as x approaches 3 from the right of the function. Now since x equals 3 is included in the function on the right hand side, these two are exactly the same, so it will suffice for us to just show that the limit as x approaches 3 from the left of the function g of x is equal to the limit as x approaches 3 from the right of the function g of x. Okay, so let's go ahead and set up an equation using these limits, and then when we solve it, we can determine what the value of a is. Alright, so g of x, when x is less than 3, or x is approaching 3 from the left, we have the function 2x minus 5. So what we're evaluating is the limit as x approaches 3 from the left of 2x minus 5, and that must be equal to the limit as x approaches 3 from the right. G of x to the right of the of x equals 3, and x equals 3 included, we have the function 4ax minus 2 as a function to the right. So let's go ahead and evaluate these limits. Plug in, substitute 3 into both equations. We'll have 2 times 3 minus 5 equals 4a. Instead of x, you substitute 3 times 3 minus 2. Let's simplify this resulting algebraic equation. We have 6 minus 5, which is 1, equals 12a minus 2. Alright, so we solved this equation for a. It will tell us the value of a that will make the function continuous. To accomplish this, we'll carry out 2 algebraic steps. Add 2 and divide by 12. Let's go ahead and do that. So we add 2 to both sides. We have 12a equals positive 3. Divide both sides by 12. And then we have a equals 1 over 4. So this is the value of a that will make our function continuous for the entire domain, including x equals 3. Alright, to gain access to the main test, you can click on this button right here. To advance to the next question, question 14, click on this button. For more similar examples like this, click on more similar examples link. Don't forget to subscribe for updates to other tutorials such as this. Thanks again for watching and have a wonderful day.